Good morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with RF Elements. Today's host is Tassos Alexou. He is presenting today, and if anyone has any questions, please feel free to submit them in the question box, and I will ask them of Tassos at the end of today's presentation. Tassos, I'm finished for now. Thank you so much for being with us here today. So go ahead and take it on over.
Great. Thanks for having me. Good morning and good afternoon, depending on where you are watching this webinar today. My name is Tassos with RF Elements, and I'm kind of the product expert marketing guy. And today we'll be going over our product overview. So this will be an overview of all our current hot products that we have right now as far as antennas and adapters and such. So if we look at our product map here, we have it broke down by types of antennas and also our adapters that we have for different radios that are on the market today. And so when we start, we'll start with our adapters, talk a little bit in depth on how they work, how they kind of plug in and play with the antenna offering we have and their compatibilities to different radios on the market. And then we'll go into the antenna specific stuff. And again, how these products can be used, the benefits of our products versus other products on the market and so on. So we'll start with our TWISTPORT adapter system. Sorry here, I'm having a little, there we go. So this is our TWISTPORT. This is our proprietary patent pending TWISTPORT technology. The TWISTPORT is what allows us to connect radios into our antennas effortlessly and eliminating the use of pigtails and jumpers, basically creating a waveguide fed interface with virtually zero loss, and it helps you achieve excellent RF performance. Our TWISTPORT also combines the radio mounting and the RF connection all in a single interface, so it's extremely easy to use and safe to operate. And the TWISTPORT is really not only just an RF connector between the radio and the antenna, but it also mounts the radio to the antenna at the same time, right? So once you insert the twist locking adapter into our TWISTPORT, everything stays locked and really creates a weatherproof seal and eliminates many issues, not just signal issues, but also water ingress and other issues that you have with conventional, traditional antenna radio connection interfaces. So our TWISTPORT concept here, was really developed and thought up back in like 2014. So we brought it to the market where, we said, hey, let's get rid of these connectors on a radio and integrate an RF feed or create a waveguide fed radio system to make radios way more efficient. So this is today's new industry standard for radios today. So by eliminating the pigtails and then therefore putting the waveguide fed mechanism onto the actual radio itself and creating this TWISTPORT waveguide fed interface, we get near zero loss, much more efficient RF transmission from the radio to the antenna, and therefore more efficient overall RF spectrum. So what is a TWISTPORT adapter? A TWISTPORT adapter is really a simple device that allows you to convert today's connectorized small factor radios into a waveguide fed. So if we look inside the adapter, we can see there's small pigtail connectors that interface the connectorized radio and convert it into a waveguide fed radio apparatus. The adapters still have pigtails inside and they're still connectors, but they're highly controlled as far as loss and VSWR. So we're able to minimize the loss dramatically and therefore still deliver you very efficient RF transmission from your current connectorized radio systems into our TWISTPORT waveguide fed antenna systems. So TWISTPORT adapters connect to any TWISTPORT antenna that we offer. So this is something that most people don't currently know, or maybe they don't understand. The TWISTPORT adapters themselves are made specifically for specific radios. However, if you have a radio with a TWISTPORT adapter, that radio and adapter will work for any of our TWISTPORT antennas, whether it's a symmetrical horn antenna, our new asymmetrical horn antennas, our ULTRADISH parabolic dish antennas, or even our large point-to-point ultra horn antenna. If the antenna that we offer has a TWISTPORT on it, then your adapter will work with any of those radios. So one radio, and we let the antenna do the work to create the beam patterns that you need for that specific antenna. So as I mentioned earlier, the TWISTPORT adapters are specific for the radios only, not the antennas. So we support multiple radio manufacturers on the market. Cambium Networks is one of those supported radio manufacturers that we make TWISTPORT adapters for. So here we have the TWISTPORT adapter for the EPMP 1000 radio. You can see it's a very simple interface. You simply take either the EPMP 1000, and there's I think 3 variants. There's an EPMP 1000, a 1000 Lite, and maybe a 1000 Sync. All 3 of those radios share the same form factor. Therefore, the TWISTPORT adapter for EPMP version 2 works for any of those 3 EPMP 1000 radios. For Cambium, we also support the EPMP 2000 radios. So again, just like the EPMP 1000, the adapter is just a very specific form factor for this new radio, and you can see how easy we make it. You just simply take your connectorized radio and you slide it up into the adapter and it locks in place. Pressing a little release button allows the radio to drop out, right? So you simply slide it in, click and connect, and then your TWISTPORT adapter and radio is ready to work with any of our TWISTPORT antennas that we have on the market today. If you're a Microtech user, we also support TWISTPORT adapters for the Microtech router boards, basically the square form factor router boards. So the 9 series, the 7 series, and the 4 series, like the 411, 711, 911, 912. I believe the 411U is the only router board that does not work in our TWISTPORT adapter for Microtech. So here we're looking at our plastic enclosure TWISTPORT adapter for Microtech. So you can see here we have, I believe this is like a 922.5 board. You simply put the board on the inside slider, you connect the MMCX connectors, and you slide and lock it up into place. And now that 911 is now converted into a waveguide fed radio system. So this TWISTPORT adapter for router board plastic is one of the adapters that we offer for Microtech router boards. If you're looking for a little bit more robust EMI protection, we have the TWISTPORT adapter for router board cast aluminum. So this one is made again for the same router boards, also includes the support for the new M11 series of router boards as well. So again, it's the same type of setup. The router board goes inside the enclosure, and then the MMCX connectors allow you to convert that RF output into a waveguide fed, again using very low loss, very high grade cable connectors inside the adapter. For Ubiquiti networks, we support many of the radio platforms as well. I think Ubiquiti is probably the largest offering of adapters where we make many adapters for a lot of their radio systems. So to start here, we have the TWISTPORT adapter for ISOSTATION, or the adapter IS. This adapter is made specifically for the round form factor radios that Ubiquiti currently has on the market. These are Ubiquiti's waveguide fed radio system. So the TWISTPORT adapter for ISOSTATION is simply just a waveguide adapter to convert their proprietary waveguide output into our TWISTPORT system standard. So basically you just twist and lock it in place. There's a little protective shroud that comes on, and then you're able to just twist and lock it into any of our TWISTPORT enabled or TWISTPORT antennas that we have on the market. The support for compatibility are again for many different types of these ISOSTATION type or round radio form factors from Ubiquiti. So if you're running the ISOSTATION M5 or the ISOSTATION 5AC, if you're running the larger Ubiquiti PRISM Station AC, or even their future Ubiquiti AirFiber LTU radio, this one ISOSTATION adapter works for all of those different waveguide radios from Ubiquiti. So one adapter for about 4 different radios. If you're running the Rocket 5 AC Prism or AirFiber 5X, we have our TWISTPORT adapter PAF for Prism AirFiber. It's a single adapter, again, for multiple radios. Here you can see there's an add-on adapter for the AirFiber, which would allow you to align it and then insert it into our adapter as well. So again, multiple radios supported through a simple TWISTPORT adapter. This adapter is also extremely unique compared to our other offerings in that it actually has GPS antenna integration, or a slot to mount your GPS antenna. So you no longer have to look for a ferrous metal pole or some sort of strut on your tower that the magnetic GPS puck can attach to. With our PAF adapter, you take the included GPS antenna that comes with your radio, and you have a nice little hiding spot to put it in there, wrap your cable around the adapter itself, and then protect it from the elements and also birds, because we know that the cables on the GPS pucks like to be eaten and played with as well. So there's a nice seamless integration for GPS synchronization antennas into our adapter. So it's really multifunctional. As far as the radio platforms go for this particular adapter, again, it supports the Ubiquiti Rocket Prism 5 AC, also known as like the Generation 1, the Ubiquiti Rocket Prism 5 AC Gen 2, the Ubiquiti AirFiber 5X, and the new Ubiquiti AirFiber 5X HD, which is also known as the LTU radio as well. So again, one adapter for all 4 of these different radio platforms will again make these radios compatible with any of our TWISTPORT antennas that we have on the market. If you're running more legacy equipment, we still have TWISTPORT adapters for the old Rocket M5s. These are the older 802.11n radios that are out on the market. So if you still have some of these out there, or you're still looking to use them, again, we have the TWISTPORT adapter RM5 that will allow you to, again, convert that radio into a waveguide and then allow you to tap into all the different antennas that we have available on the market today. And then finally, the older Rocket 5 AC. This is also, I believe, known as the Rocket 5 AC Lite. By most people. I believe this is like the first generation AC radio from Ubiquiti. Again, if you have any of these on your network, or you have any of these radios laying around and you see a place to use them, we have a TWISTPORT adapter available for it, and it's the TPA R5 AC. Again, the same simple slide in and connect, press the release button to drop the radio out. So seamless integration and simple implementation for any of these radios with our antennas. Next, we also support Mimosa networks. So if you are running the C5C radio from Mimosa Networks, we have an adapter for that as well. So if you're using it for point-to-point or CPE, you can use the TWISTPORT adapter C5C to convert that into a waveguide and then allow you to integrate that radio, again, with any of our TWISTPORT antennas. And then finally, for all other radios on the market. So the TWISTPORT adapter is well suited for today's kind of small form factor radios, right? As you've seen, the Ubiquiti, Cambium, Mimosa, and Microtech type radios. There are a lot of other radios on the market that are much larger form factors. They're just big and clunky, have huge heat sinks, have huge end connectors on them, or what have you. So for any of those other radios on the market that do not have a supported TWISTPORT adapter for, we now have our connectorized adapter. So the TWISTPORT adapter SMA is simply that. It's just an adapter with two SMA connectors on there that will allow you to, for instance, connect a PTMP 550 from Cambium to any of our antennas, or perhaps an A5C from Mimosa as another option. Even the PMP 450 series from Cambium. Again, really any 5 gigahertz outdoor radio that we do not have a TWISTPORT adapter for, you can simply use the TWISTPORT adapter SMA with some LMR jumpers to connect those non-supported or large form factor radios, and then still utilize all of our great TWISTPORT adapter antennas on your network. So now we're going to move into our symmetrical horn TWISTPORT Gen 2 antennas. So our symmetrical horn TWISTPORT series is a like our first horn antennas that are on the market. They possess they have a symmetrical beam pattern, so it makes them kind of unique on the market just from the beam pattern itself. So the beam pattern is symmetrical. So if we look at the azimuth cut and the elevation cut, they are identical. So the beam is just as tall in elevation as it's wide in its azimuth. So it's a very symmetrical beam pattern, which makes it very unique and has a lot of very unique characteristics to the antenna pattern that we'll look at here. So if we compare the beam shape of a traditional patch array sector on the left to a symmetrical horn antenna, again, the difference is quite obvious. The patch array sector has a very non-symmetrical beam. It's usually very, very wide in the azimuth and very narrow or tall in the elevation. Also, you can see that the patch array sector, or your traditional sector that we have on the left, also has many, many complex side lobes coming off the top, the bottom of the beam, off to the sides of the beam, and even out the back of the antenna. Our symmetrical horn antennas have absolutely 0 side lobes, which is very important in creating very precise radiation angles and giving you very high control over your RF deployment on your network. So if we look here on the left, we can see the RF simulation of a 90-degree horn antenna. And you can see that it's very precise, very symmetrical, and again, a very clear-cut beam pattern. If we look at a competitor's patch array 90-degree sector on the right, you can see how it radiates way past 90 degrees through side lobes, and also leaks out lots of RF out the back of the antenna as well. So these makes patch array traditional sectors very susceptible to noise, because they're hearing beyond their subscribed beam angle, and therefore makes them more susceptible to noise, because it can receive outside of its intended coverage area, as well as generating a lot of noise because it can send and does send signal outside of the coverage area. So it makes co-location very difficult and a lot of other issues. Our symmetrical horn antennas also have very small null coverage or dead zone. So if you look at the symmetrical horn, the dead zone from the tower or at the base of the tower, you can see that it's much more reduced compared to a traditional sector. So your close-in customers to the tower will get much better main beam connectivity, as well as the customers far out from the tower, where with traditional sectors, you usually get better signal farther away from the tower, and you get side lobe connectivity or no connectivity close to the tower unless you include a lot of down tilt, and then that changes your coverage area. So the null coverage of our symmetrical horn antennas is quite impressive and very helpful for many WISPs on the market. Another one of the really outstanding properties of our symmetrical horn antennas is the frequency stability that we get. So here, if we look at the beam pattern shape in the 3D radiation pattern or in the two-dimensional coverage area on the right, you can see as we change frequency, the beam stays extremely stable. So you're not really changing the coverage area and you're not changing the performance of the antenna because, again, it's extremely stable at a very wide frequency range. If we look at the same thing on a traditional sector, you can see that it's very unstable at a different frequency. So if we look at the 3D radiation pattern on the left or the two-dimensional coverage area on the right, you can see how as you change channels, your coverage area is changing, your signal intensity is changing, your side lobe growth is changing. Really, this is creating huge problems for you. This is one of the biggest issues with traditional sectors that people run into. When you have your system deployed and you have your customers online, and then noise happens, and so you change to what you think is a clean channel, and all of a sudden you have customers fall off or signals change dramatically just by changing channel. And the reason for that is because the RF characteristics of your old traditional patch array sector is changing so greatly that it's affecting performance. So this frequency instability is truly killing your network. Not only, again, changing where noise is being heard and where noise is being sent, but affecting the signal that's connecting to your CPE. So frequency instability is very bad with traditional sectors, and our horn antennas are much more stable. Well, finally, we'll talk about signal density. So not only do our symmetrical horn antennas have very precise radiation angles, they also have a very high signal density. And what this means is that as you start looking at the signal drop-off as you move away from the center point of the antenna, gain drops off dramatically, right? And this is really important because if you look on the right, you can see a traditional sector, and you can see as you go beyond its main spec, or what the spec sheet says it is 60 or 90 degrees, you can see that the signal drops off extremely slow at the edge, and therefore makes that antenna have very high gain still at a much wider angle than you think you're covering. So the very high signal density of a symmetrical horn and the very steep drop-off you get as you move away from the edge is something that, again, helps you reduce noise and gives you very precise coverage areas from our antennas. So something that's very impressive. Our symmetrical horn series come in 7 different sizes or 7 different beam patterns. So we have everything from a 30 degree to a 90 degree in 10 degree steps. So we have a 30, 40, 50, 60, 70, 80, 90, right? So as we go wider with the beam, you can also see that gain changes as well. So again, there's a very large number of different beam patterns and gains that are available for all of our antennas. They're also very compact. You can see they're about a quarter of the size of a traditional patch array sector. So this allows you to co-locate way more antennas in the same vertical space as a traditional sector. It really is a co-location miracle because you're able to, again, get that very high AP density you need for very dense customer deployments, and again, really cancel out all the noise, which helps you grow your throughput and not really stagger your growth. As you can see on the right with competing sector antennas, the noise reception of all the side lobes really decrease your throughput and create a lot of issues for you and makes very high density deployments very difficult. And we've fixed that problem. Here you can see in the field, these are real life installs from WISPs like yourself. So you can see that you are actually able to co-locate these antennas very close to each other, way closer than you would ever try with traditional sectors. So they actually do work. The noise isolation is so great that co-location is really like nothing we've seen before. And then finally, it gives you really massive scalability, right? So it gives you the ability to create a network and direct coverage where your customers actually are and ignore coverage where your customers are not, and therefore giving you really good noise isolation and frequency coordination by adjusting gain and giving you the ability to, again, be sensitive to where your other towers are, where your customers are, and really only send signal where you need it and only receive signal from where you want it. Our antennas are very durably built, right? So we use very high quality UV resistance plastics, die-cast aluminum, stainless steel, and other products. The materials that we've been using in our antenna products for almost 10 years now, 8+ years. So we know that these products are rust-free and durable and that they're made to last in the elements. Again, finally, some last deployments to show you here again how stackable these antennas are and how well you can co-locate them together. So now we'll talk about our ultra-horn TWISTPORT antenna. So the ultra-horn is a very narrow beam horn. It's much larger than our other symmetrical horn antennas. It has a very narrow 15-degree beam width with 24 dBi of gain. So again, this is a very highly focused horn antenna with really high gain. So, the ultra horn has a symmetrical beam pattern like our other symmetrical horn antennas, but it's highly precise as far as its beam goes because it's very narrow and focused compared to some of the wider beams that we have in our symmetrical horn antennas. Just like the antennas we previously spoke about, it's still our horn antenna technology, so it's very frequency stable. If we look at the 3D radiation pattern and the two-dimensional coverage map, you can see as we change frequency, or as we sweep through the frequency, you can see how stable the pattern is and doesn't deviate like other antennas in the market do. Our ultra horn also has 0 side lobes. So if we look on the left of the parabolic dish antenna, a 3-dimensional shape, you can see the very complex side lobes and really high gain of these side lobes, which help you hear noise, not that it's helping you, but helps you see noise from further distances, and therefore really creates problems for co-locating close on your tower, but also with other towers as well, where the ultra horn on the right has absolutely 0 side lobes. The shroud effect is something we've been talking about for a while, but we're finally trying to show you. So a lot of people think that parabolic dish antennas, if you put shrouds on them, they kind of fix the problem of side lobes for you. And in fact, they don't. They just really move the problem. So if you look at the simulation on the left, you can see a standard parabolic dish antenna without a shroud on it and all its glorious side lobes. So you can see, secondary and third lobes coming off the center point, as well as leakage out the back. And then at 180 degrees or perpendicular to the main beam, you can see them coming out the sides. If you look on the right, you see that same antenna with a shroud put on it. So you can see that all the shroud really did is moved all those side lobes forward some. So it created more kind of co-location noise immunity. So the leakage out the back has been reduced some, but you can see that the side lobes are still there and they've actually changed in intensity and in angle. Another thing to mention about shrouds is that people often look at the spec sheets from manufacturers on antennas and they look at the polar plot, the beam angles of the antenna and how they perform, and they judge the accuracy and performance of the antenna based on that. Once you put an aftermarket shroud on your antenna, that spec sheet is no longer valid because you've changed entirely the beam performance and the side lobe performance of that antenna, so it's no longer valid and therefore kind of useless for you to judge that antenna metrics anymore. If we look at it in more of like a two-dimensional, we can see here when a shroud is added onto an antenna, all it really does is it takes those side lobes that were there before and compresses and pushes them forward. So it's actually changing more of the forward-facing radiation, the one that you need to connect to your other side of your link, and adversely affecting that in order to try and achieve some better co-location capabilities and reducing some of the back radiation or hoping to improve front to back ratio a little bit. So it may help you co-locate on the tower, but it's affecting your link beam, which is really more important. If we look at true noise rejection on the left, we can see the ultra horn. So you can see it's very precise, very stable, and zero leakage out the back. If we compare that to a parabolic dish antenna, I think the choice here for noise rejection is quite obvious. Even if you had a shroud on it, there's really no comparison to an ultra horn compared to a parabolic dish antenna with any kind of shielding. We also have the ultimate gain performance. So if you look at the gain across the spectrum, you can see it's extremely stable. Again, when you buy parabolic dish antennas today, they often spec the highest peak gain in a single polarity, kind of the highest number they can find to put on that box. So that way you think you're getting the highest gain. And really when you start changing channels around, that gain deviates greatly, right? With our ultra horn, you can see that gain is very stable, plus or minus maybe 1 dB across the spectrum. So very good performance. Also very easy antenna alignment. You can see with parabolic dish antennas, because they have very large side lobes, you can have the antennas misaligned and still see strong signal intensity and therefore not have main beam connectivity, where with an ultra horn, you're either in main beam connectivity or not at all. So again, when you align the ultra horn, it's very easy to align, and you really reduce the ability of making mistakes because you cannot have a side lobe connection. So you're either in main beam and have a perfect link, or you're out of alignment, and it's quite obvious which is which. So people also ask, you know, I mean, is it really a high performance point to point, or is it also point to multi-point? Really, it can be both. The antenna doesn't really care. So as long as your cluster of radios are within the ultra horn's beam pattern, again being very narrow, there's no reason why you couldn't use the ultra horn also for very high density point to multi-point as well. So it's all possible without a doubt. The choice is really yours. Like all of our antennas, again, they're a very durable build, right? So again, we use very high quality stainless steel, aluminum, and other choice types of metals and plastics, right? Like zinc and aluminum. Again, really, these antennas are made to last in the elements out in the field for a very long time and not corrode at all. Here we can see some deployments. If you look at the picture on the left and in the center, you can see some of those very high density point to multi-point using the ultra horn antenna here with, I believe, PRISM radios from Ubiquiti. On the right, we can actually see one point to point. This is actually a point to point. It's 15 miles long, 15 miles with 24 dB. This 24 dB ultra horn actually replaced 30 dB dishes and created a perfect MCS 1415 stable link for almost a year now. I think it's been running for 6 to 8 months. So again, really great performance. Even though it's lower gain, it's still capable of doing links longer than higher gain antennas do in many applications. Again, we can see how well they co-locate even between two sector antennas. The noise isolation of the ultra horn is just untouched in the market today. So the next product we'll talk about is our ULTRADISH. So this is our parabolic dish antenna line with, again, TWISTPORT adapters built into it, or a TWISTPORT antenna. We offer two different sizes. We have a 550 millimeter, which is basically 27.5 dB, so it's our ULTRADISH 550. And then we also have a 400 millimeter, or a 24.5 dB ULTRADISH 400. Again, both of these ULTRADISHs are TWISTPORT antennas. So this is a parabolic dish, and therefore it still has side lobes like all parabolic dish antennas do, but we're able to actually create it to have suppressed side lobes. So even though it still has side lobes like any parabolic dish, we've actually done a really good job of suppressing those side lobes and therefore creating the isolation that you need without the use of a shroud. We also have some of the most stable gain for a parabolic dish antenna. Not only is it stable across the spectrum for the lower 5 gig all the way up to the upper uni, from uni 1 to uni 3, but we also maintain that same gain in both polarities. So it's very important to understand the difference. Again, a lot of manufacturers actually stopped showing you the gain curve in their spec sheets. And for the ones that sometimes do, they show you the average gain of both polarities. So they don't show you the vertical and horizontal gain and what the relationship is across the spectrum where we do. So here you can see the ULTRADISH 400 on the left and the ULTRADISH 550 on the right. And you can see that the gain is, again, extremely stable across the spectrum in both horizontal and vertical polarities. So all of our antennas, whether it's ULTRADISH, ultra horn, or symmetrical horn, we have very stable gain in both polarities across the entire usable spectrum. These can also be used as CPEs in high gain areas. So a lot of people are using these patch array antennas, these square patch panels, which have very complex side lobes. And in very dense areas, you can see that the CPE antenna can hear multiple APs because of the very large side lobes. Where with the suppressed side lobes of our ULTRADISH, you can see that you have the ability to now exclude and not hear multiple APs. This is not always going to happen. It depends on the deployment and where the APs are. But because the side lobes are suppressed and they're not as complex as a lot of these square patch panel CPE antennas that are on the market, you can see that they work really well as CPEs in high noise environments. The ULTRADISH also has our very innovative mount. So you can see it's very simple, just 2 screws to attach the mount, which is included, to the pole, and then you simply slide the antenna into the receiving slot. You adjust your angle and then tie in the azimuth, and then you adjust your elevation angle, and then you tighten the elevation bolts. So very simple, 2 bolts. You can install this antenna on a tower with almost one hand and practically no tools, right? So it's very, very simple, 13 millimeter bolts, and you're good to go. So very innovative mount and quite different than the U-bolt, square pressed L brackets that many manufacturers are still using today, technology from many, many moons ago. So very innovative mount from RF Elements, unlike other manufacturers on the market. Here you can see the ultra horn in the wild on some deployments out here, again being used not only for point-to-point, but also as CPE. So you can see it with PRISM on the left, radio from Ubiquiti, in a point-to-point configuration. You can see it with a C5C in the middle in a point-to-point configuration. And you could also see it with a C5C on the right as a CPE as well. So again, multiple uses from a single antenna. Now we'll move on to our asymmetrical horn antenna with TWISTPORT. So the asymmetrical horn TWISTPORT series is our newest antenna on the market. We need to update this. The availability was supposed to be February of 2019. It's been pushed to March now, so we're a month delayed from what we promised. But the asymmetrical horn comes in 3 different sizes. So now we have a 90 degree, a 60 degree, and 30 degree asymmetrical horn antenna. The thing to really look at here is the gain relationship here. So our current 90-degree symmetrical horn antenna only has 10 dB of gain. The 90-degree asymmetrical horn now has 16 dBi of gain. So it's a 6 dBi increase in gain. Our 60-degree asymmetrical horn has 17 dBi of gain now compared to, I believe, 13 dBi of the 60-degree symmetrical. And then our 30-degree asymmetrical has 20.5 compared to 18. So by, again, changing the beam pattern, we're able to increase the forward gain in the same wide angle with different characteristics. So unlike our symmetrical horn, our asymmetrical has a asymmetrical pattern, right? So the beam is in our 60 degrees wide in the azimuth and 25 degrees tall in the elevation. And our 90 degree is 90 degrees wide in azimuth and 25 degrees tall in elevation. We still give you perfect coverage patterns with very little null zone as well. So you still get the same benefits of the symmetrical horn antennas in an asymmetrical beam shape. We still possess 0 side lobes. So if here we look at an asymmetrical horn antenna on the left, you can see again how beautifully the pattern comes out of the antenna with 0 side lobes and no leakage out the back compared to the kind of old patch array sectors that most other manufacturers are still making today. So 0 side lobes. Like all of our horn antennas, we still have very stable frequency, right? So the frequency stability of our asymmetrical horn is like all our other horn antennas. So if you look at the 3D radiation pattern on the left or the two-dimensional coverage area on the right, you can see as we sweep through the frequency, the pattern and the frequency stability of that pattern is very good compared to others. Here is something that's very important, is that we also have very balanced horizontal and vertical beam coverage areas, right? So if you look at a traditional sector on the right, you can see that the horizontal and vertical beams rarely match. So usually one beam is wider or narrower than another and has a different shape. With our asymmetrical horn, we're able to give you a horizontal and vertical beam pattern that's practically identical. So this really helps fix a lot of those chain-to-chain issues that you see, or those mismatched chain errors that you get as you go to the edge of the sector of a traditional sector, and our asymmetrical horns will not have that problem. The asymmetrical horn was really created for rural deployments for the most part, right? So this is where you might have a WISP that has a lower density of customers, but still requires to go a larger distance, right? So the asymmetrical horn gives you all the noise isolation capabilities, all the noise rejection capabilities that you expect from our horn antennas, but now with a wider beam and higher gain. So you don't have the problems that you get with patch array sectors where side lobes create noise and hear noise from unintended directions, therefore giving you the best network throughput. With the 3 different sizes, the 30, 60, and 90 degree, we still give you the ability to create coverage patterns based on where your customers are, right? So even though the coverage, the antennas only come in 3 different beam angles, you still have the flexibility because of the highly precise beam angles. You have the ability to, again, create your coverage area for rural deployments and still send signal where you need it and only hear signal from where you want to hear it. Just like all of our antennas, it's a very durable build, again, using all the same zinc, aluminum, and UV rated plastics in all of our antennas. So quickly, we're going to go through our symmetrical horn carrier class antennas as we come here to an end. So the symmetrical horn carrier class is is just like our symmetrical horn twist port that we spoke about earlier, the first antenna. The difference here is that they come with end connectors built on. So again, for any radio that does not have a twist port adapter for it, and you want to use a symmetrical horn pattern, the symmetrical horn carrier class is available for you. Has all the same RF performance as the twist port version, just has integrated end connectors to make it easier for you to connect radios that are not supported. Still in all different beam angles from 30 to 90 degrees and 10-degree steps. We also have our ultra horn carrier class. So just like the twist port one we spoke about earlier, all the same RF characteristics and gain and performance, just with integrated end connectors in a non-twist port form factor. And again, if we look at them again in the field, you can see here is a Mimosa A5C with some carrier class symmetrical horns. Again, simply using LMR cable, you can attach those radios to our antennas without the use of an adapter. And then finally, our carrier class sector. So this is our legacy antenna line that we have. So the sector carrier class series is an antenna product that we've had on the market for close to 8 years now. We have two different models. We have a 14 dBi 2.4 gigahertz version that's 100 degrees wide. And we have a 20 dBi 5 gigahertz version, which is also roughly 100 degrees wide, all measured in the -6. What makes this product very unique is that we've integrated or built a back shield into the antenna since day one. So our back shield is not just a piece of flat aluminum or flat metal. It actually has special frequency selective surfaces. So these are like RF tuning chokes and RF tuning surfaces that allow us to not only attenuate and block the signal out the back so you get good co-location capabilities, but more importantly, helps us shape the beam forward. So unlike traditional sectors on the right, you can see on the left, our carrier class sector still has very balanced horizontal and vertical beam patterns. So even in an old traditional sector type technology, with our integrated back panel or back shield, we're able to deliver great chain-to-chain performance throughout the entire antenna coverage area, right? So again, we don't require, you're not required to, or you don't need to put aftermarket shielding. We've done the best thing. We built that shielding in and we tuned it specifically for that antenna from the beginning. So this is, again, an antenna product that's on the market now. Here you can see some great co-location capabilities of the sectors. There also has the click-in mount in the back. So for all the common kind of ubiquity type of slide-in rockets and stuff like that, our antennas allow you to do the same thing. So you don't need any special adapter. So it should work just as well as any of your other antennas do. So really at RF Elements, we're setting new standards for the industry, right? We introduced the noise rejecting horn antenna to the industry over 4 years ago, and we're seeing it now being adopted by a lot of the other manufacturers. So something that we brought to the market first in creating this new standard. Also the zero loss system or a waveguide system. So again, this is a new industry standard that RF Elements set for the industry, and now we're seeing people follow. When you bring this zero loss system that we introduced to the market over 4 years ago, and this noise rejection kind of ideology and thinking methodology of using antennas, lower gain with better noise isolation versus higher gains with bigger side lobes, our noise rejection and our zero loss system really gives you the massive scalability that the industry requires today. So as the need for internet grows and the need to deliver more and more internet connections and increasing the speed of those internet connections, the massive scalability that WISPs need to successfully stay in business today, RF Elements delivers that to you. So as a kind of wrap up here, really again, we'd like to focus on the durability of our builds. Again, we use some of the highest quality materials on all of the antennas that we create. Something to make a special note about is that we do use stainless steel hardware, unlike many other manufacturers. Almost like most manufacturers use galvanized steel, which the galvanization eventually starts to erode, or it's not done very well, and therefore your bolts and mounting apparatus and even antenna starts to oxidize and rust, right? So our stainless steel hardware is made to last, and because it's stainless steel, you need to use an anti-seize lubricant, right? So you can get this at any auto parts store or Home Depot. It's just an anti-seize lube, which helps reduce the friction of the threads, and therefore when you use stainless steel hardware, you won't have a problem of those bolts seizing up, and they'll last forever. So very important thing here. We've also changed our ecological packaging. So we use recycled cardboard now, just something to note. We use more compact methods for packing our product and use less styrofoam. So a little bit more environmentally friendly. I'd like to talk about our YouTube channel, right? So we have a lot of customer testimonials. You know, I do a lot of these webinars and I talk in public a lot about our antenna products, and obviously nobody ever really wants to listen to the salesperson, and I get that more than anybody. So, you know, go to our YouTube channel. I mean, it's a great place to connect and see WISPs like yourself, right? So hear it from the actual operators, your brothers and sisters in the WISP industry, how they use our products and how it really helped them grow their networks or fix issues. So it's best to hear from them and not from us. And on our YouTube channel, not only do we have customer testimonials, but we also have, you know, previous webinars and other great information that you can watch. We also have a very active forum online, so join our online community at rfelab.com. Again, another great resource to get information, see questions that other people ask that you may have the same question, and therefore be able to kind of answer your questions or ask new questions. So a lot of great information there. And then finally, our trademarks disclosure. So this is to show that all third-party trademarks are used solely to reference compatibility of RF Elements products. All rights and respective trademark owners are reserved. And then finally, we go to our Q&A. So I'll turn it over to you, Sue. If you have any questions that come up, I'd like to take them now, or I can take them now.
Tassos, thank you very much for that presentation. And yes, it looks like I do have a few questions for you. Let's go ahead and get started. You touched on some of this, but can you tell us the name of some of the other brands that you have TP adapter models for?
Yeah, absolutely. So currently in the portfolio, we currently supply, or we manufacture adapters for Ubiquiti, is the one manufacturer, and there are multiple adapters. There's the ISOSTATION, the PRISM station, the LTU, there's the air fiber, the Rocket 5 Prism, the old Rocket M5, the Rocket 5 AC. There's still some adapters for other Ubiquiti radios out there. That's kind of our legacy product line. They're not being manufactured, but you still might be able to find them for Ubiquiti. For Microtech is our other manufacturer that we support. Again, there's support for all of the small square form factor boards like the 911, 411, and 711, and now the new M11 type boards. So if you're a Microtech user using any of those boards, and again, all this information can be found on our website as well. So feel free to go to rfelements.com and go to the specific manufacturer you want, and you'll see what's supported there. Beyond Ubiquiti and Microtech, we support Cambium as well. So if you're running the EPMP 1000 or the EPMP 2000, both those radios are supported from Cambium. And then finally, Mimosa. Currently the C5C radio from Mimosa has a TWISTPORT adapter. For all other 5 gig radios from manufacturers that I did not mention, you could either use our carrier class antenna line, which have end connectors on them, or you can use our TWISTPORT adapter SMA to allow you to, again, take this a non-supported radio platform and integrate into our TWISTPORT antennas with a SMA TWISTPORT adapter. I hope that answers that clearly.
Yes, thank you very much, Tassos. Great. Next question here for you. Regarding frequencies, at this time, do you guys support only the 2.4 and 5 gigahertz?
So in our horn antenna and dish antenna, really, I mean, as a company, currently 5 gigahertz is really the only supported frequency that we have across the majority of our product line. There's really only one 2.4 gigahertz antenna, and that's that old traditional carrier class sector that we showed. None of the horn antennas or parabolic dish antennas support 2.4 gigahertz. Again, we have some legacy 2.4 gigahertz omnis. So as a company as a whole, really 5 gigahertz is the focus at the moment, and the only thing that you can find from us on the market right now.
Excellent. Thank you very much for that.
Mm-hmm.
Question here. Is it any horn to any antenna? Can you elaborate on that for us?
Any horn to any antenna. I'm not quite sure what that question is trying to ask, what that person is trying to ask. If you can follow up, I'll try and answer it based on what I think you're asking. So if I don't, please retype in your question, maybe to clarify a little bit.
Okay.
Something I tried to clarify, and clearly you can see I was kind of pushing the message here. It's any of our adapters will work with any of our TWISTPORT antennas, right? So it's the TWISTPORT adapters that are made specifically for a single specific radio. Once you have an adapter with your specific radio, you can use it on any of our antennas. Now, I'll take it one step further as far as the horn or antenna to antenna. If you're talking about how to use our antennas, like can you have an ultra dish talk to an ultra horn, or an ultra horn talk to an asymmetrical horn from us? Yes, it doesn't matter. The antennas don't care what antenna it talks to in your point-to-point or point-to-multi-point. If that was clear and I answered your question, that's great. If not, please re-ask it, and I'll be happy to answer it. And also, if anybody else has questions still and you haven't typed it in, please go ahead, and I have time, so no problem taking more questions.
Thank you so much, Tassos, for that. I do have some lined up here for you, so I'm just going to go to the next one.
Great.
Okay, here it is. Is there any way to purchase the port part itself to upgrade the existing antennas?
Is there any way to? Well, no. So we don't sell the TWISTPORT, whether it's the male part on the adapter or the female part on the antenna itself. We actually do have, so the TWISTPORT mechanism is our kind of proprietary in-house technology that we created. We actually have a kind of an open licensing for it. So if you're trying to make an antenna or something, or you have a radio that you want to make a TWISTPORT adapter for to work with our antennas, you can go to our website, rfelements.com, and scroll to the bottom of the page, and you'll see our TWISTPORT developer group, right? So you can actually sign up for that if that's where you're trying to go with this. And we can, again, do something to allow you to develop your own radios or maybe your own antennas with our TWISTPORT kind of form factor. I hope that answers your question.
Yes, it does. Thank you so much. Next question here for you. In regards to the link calculator, can you tell us a little bit more about that?
Yeah, so the link calculator is really a great tool, and it's actually been working fairly well as far as accuracy goes. First, if you go to our website, rfelements.com, and you go to the link calculator page, there actually should be 2 videos on there on how to use it. So I'll just talk about it briefly about some of the things that you can do. So when you go to the link calculator, you'll have the ability to plot your points, right? So you put where point A is and point B is, right, for the link that you're trying to make and the link budget you're trying to calculate. Then there's a drop-down menu which will allow you to choose any of our current antennas, whether it's the ultra horn, ultra dish, symmetrical horn, and even our new asymmetrical horns, I believe, are on there as well. So you pick the antenna you want, you add the TX power of the radio to keep yourself in EIRP limits, and then you'll have the ability to put the antenna gain of the other side of the link. that you have. And again, it'll show you the link path, whether it's obstructed or not. It'll tell you the projected signal strength that you should get at that specific distance. On top of that, you also have the ability to adjust the MCS rate. So there's a lot of different radios. Some radios are still 802.11n, some are AC, some are going beyond, whether it's 64 QAM or 1024 QAM modulation. There's a slider, so you're able to actually adjust that QAM rate, and it'll show you the relative distance at that higher or lower modulation rate, including the ability to adjust down tilt as well. And then finally, you have the ability to do not just point to point, but there's point to multi-point, where you can put in multiple CPEs within a beam coverage area. And again, it'll show you what those signals will be at those different points on the map.
Excellent. Thank you very much, Tassos. Next question here. Are the TPAs tested in harsh weather conditions such as snow and rain?
So I'm sorry, are the antennas tested in harsh environments?
Yes.
Yeah, absolutely. So, you know, our horn antennas have now been out for, again, going on close to 5 years now, right? So yeah, I mean, they've been tested. We have deployments all over the world. So again, if you look on our Facebook page, if you look on our forum, you'll see deployments, or on our YouTube channel, everywhere from the hot deserts of Iraq to really cold environments in Alaska and Northern Europe and even Russia for cold environments, to very salty environments in New Zealand, on the coast, Miami near the beaches. So really, our antennas have been out there in the elements in practically every configuration or every type of harsh environment that you can think of, from hot to cold and wet to dry.
Excellent. That definitely answers our question. Can you touch base on the hours of support that we could reach out to you at RF Elements, or to whom we should reach out to?
Yeah, so if you have a support question, you could email us at info@rfelements.com. Social media seems to be a great place. You can find me personally on Facebook and Instagram. So you can reach out to Tassos Alexiou on Facebook and Instagram. As far as hours of support, we really don't have like a set thing, but generally it's kind of 9 to 5 here in the US. And because we're also in Slovakia and Europe, at night, depending on where you're at, it's also during kind of regular business hours in Europe and Central Europe as well. So it's almost like, something like 24-hour support. But we're very, very quick to answer questions. If you speak to anybody that's dealt with us in the past, they'll tell you, especially, during here in the US, pretty much from 9 in the morning till about 10 o'clock at night, I usually respond to people via email or Facebook in an hour or less in almost every case. So pretty good support here.
Excellent. Thank you so much for answering all those questions, Tassos. And thank you to everyone attending today. And if there are any further questions, please feel free to contact your sales rep. Email us at sales@microcomtech.com. If you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. And please remember, this webinar presentation has been recorded, and it will be uploaded to our Microcom YouTube channel, so you can view it again. Tassos, thank you so much for your time and all of your information today. We found it extremely helpful, enjoyed it very much.
Great, thank you. And again, stay tuned. And here's some final resources for you guys. So our website is rfelements.com. Our forum is rfelab.com. And again, you can find us all over on social media, on YouTube, Facebook, Google+, LinkedIn, Twitter, Vimeo, you name it, we're there. So feel free to reach out to us on any of these platforms, including email, info@rfelements.com. Thank you, everybody, for attending today, and I look forward to doing our next webinar. Thank you.
Thank you.